Okay, so I'm going to be going over the points, lines, planes, and angles review. Will help you on your mastery test tomorrow. Okay, so for the first one, in page, let me get this notebook out here. Let's see, we have postulate notes on page 6. So that's what you want to go look at, where you've got these flappy, where we did these notes. All of these questions are coming exactly from these notes on page 6. So you're going to want to know these postulates for your test tomorrow. So it says fill in the blank for each postulate. Through any blank points, there is exactly one line. When talking about a line, it takes 2 points to create a unique line. B, if two lines intersect, they intersect in exactly 1 point. Okay. You can see that here. If they intersect, there's 1 point. Through any 3 non-collinear points, okay, there is exactly 1 plane. It takes 3 non-collinear points to create a surface. If 2 planes intersect, they intersect in exactly 1 line. When 2 planes intersect, it creates a line. You can see that, for example, if you were to look at this tissue box, okay, I've got a plane down here and I've got a plane here. Where they intersect, it's creating a single straight line. Okay. All right. Number 2, name 2 segments using this box. So a segment is just something that has 2 endpoints. So BF is a segment. You could also say BC is a segment, FG, DH, AE. Any 2 points in this diagram create segments. Okay. Name a pair of parallel lines. Okay. I'm going to show you a trickier one just to kind of challenge your brain a little bit. So I'm going to say BC and EH. Now I know in this picture it looks like BC is back here and EH is up here, but a plane is any flat surface. So I can connect these with a flat surface and that makes them on the same plane, which is parallel. So anytime you have lines going the same direction, that's always going to be parallel. All right, so number 4, name a pair of skew lines. When you're looking for skew lines, you're looking for lines that are going different directions but not intersecting. So there's several that I see here. We could say FE and BC, those are skew. EH and AB, those are skew. Let's see, AD and GH, those are skew. CG and AD, those are skew. Okay, lots of different kinds of skew lines. I'm going to pick these 2. Okay, going different directions, but they're not going to intersect. So we've got AE and FG. Name the intersection of plane AFE, which is this plane here, and plane HEF, that's this one here. And these intersect at FE. Okay. All right, use the following conditional to write the converse, inverse, and contrapositive, and then it also wants you to determine if it's true or false. Okay, so this is if angles are a linear pair, then they add to 180. The converse flips it. So this would say if angles add to 180, then they are a linear pair. I'll do true, false at the end. Okay. Inverse makes it say not, so this one would say if angles are not a linear pair, then they do not add to 180. And the contrapositive does both. So this would say if angles do not add to 180, then they are not a linear pair. Okay, so the converse. If angles add to 180, then they are a linear pair. So we can have we can have supplementary angles like this one. Let's say this is 40, and I have an angle over here that's 140. These are separate, so they're not a linear pair, but they're still supplementary. They still add to 180. So this statement here is false. Not all angles that add to 180 are necessarily a linear pair. The inverse, if angles are not a linear pair, then they do not add to 180. For the same reason, this one is also false. Okay? You can have angles that are not a linear pair, but still add to 180. Last one, if angles do not add to 180, then they are not a linear pair. This one is true because if angles are not adding to 180 degrees, then there's no way that they can make a straight line because straight lines equal 180 degrees. All right, number 9, what is the length of BC? Okay, so BC, B is over here at -9, and C is over here at 8. You want to find the length between 2 points. Just take the absolute value of their difference. So I can subtract -9 minus 8. And my answer, I get a negative number, -17, but this absolute value is telling you to make it positive. So that becomes +17, and that's my length. Okay. What is the midpoint of AD? Midpoint formula just says that we add our 2 coordinates, so -6 and 4, and then divide by 2. So that's equal to -1. So that's the midpoint between A and D. Okay. All right, number 11. What is the length between the given points 3, 2 and -3, -6? Okay. Anytime you're finding length, that's where you can put in that distance formula. So this is going to say we subtract our x's and square it, and then we subtract our y's and square. Okay, typing that into the calculator, you want to write it exactly like how it looks on your paper. Be careful when you're typing. Majority of the mistakes that I see on these problems come from typing it into the calculator wrong. So make sure you're typing carefully. And we get 10. All right, number 12. Find the midpoint between these given points. All right, midpoint formula says we're going to add our x values and divide by 2, and then add the y values and divide by 2. Okay, so 12 plus 6 divided by 2 gives me 9. -3 plus 11 divided by 2 gives me 4. And that's my midpoint. All right, number 13, find the missing endpoints. Okay, so here in this table, you're going to use this table to find these 2 missing points. So for example, from 4 to 7, we're adding 3, which would mean that from here to here, we would also need to be adding 3. So you have to think, okay, what plus 3 will give me 4? So in other words, 4 minus 3 gives me 1. Okay. So 1 plus 3 gives me 4, and 4 plus 3 gives me 7. All right, from -1 to 5, we are adding 6. Okay, So I do that again. And that gives me that B is 11. All right, describe how you would move point B to get to the midpoint of AB. All right, so one of the ways that you can solve problems like this is by counting the rise and run and then halving it. So if I count my rise, I'm going up 1, 2, 3, 4, 5, 6. And my run is 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I'm going to cut that in half and go up 3 over 4. And there's my midpoint. Now, it wants me to describe how I would move point B. So if I was moving point A, I would go up 3 and over 4. But if I'm moving point B, I'm going to need to go down 3 and left 4. And that'll take me to my midpoint. All right, flip to the back. Okay, so it says draw an example of each type of angle, and we've got straight, right, obtuse, and acute. So a straight angle is pretty easy. It's just a straight line, and these are always equal to 180 degrees. This is a 180 degree angle. Okay. A right angle is a 90 degree angle. Okay. An obtuse angle is going to be, let's see, it's greater than 90, but less than 180. And an acute angle is greater than 0, but less than 90. 16. Based on the picture to the right, which two of the following are false? So before even looking at this, I want to go through and label what each of these angles would be. D and B are vertical, which means that D would also be 70. A and D are a linear pair. They form a straight line. So 180 minus 70 means that A would be 110. Okay, so measure of angle D is 70 because D and B are vertical. That's true. Measure of A is 110 because it's supplementary with B. Also true. B and C are a linear pair and sum to 180 degrees. True. A and C are both 110 and they are a linear pair. Okay, the first part of this is true, but the second part is not. A and C are not a linear pair. They are vertical angles. You can't be vertical and linear at the same time. All right, number 17. Find the 1/4 point from A to B. Okay, so back when we did quarter distances, one of the ways that you can do this is to find the midpoint of AB and then find the midpoint between A and the midpoint, and that's your quarter point. Because we also learned how to do other kinds of fractional distance, you can use this same method for the 1/4 point, which is what I'm going to do here. All right, so what you can do is we're going to subtract our x values, 18 minus 2. This is giving us the length of this, of our x, of our, what do we call it, of our run. Okay, so we're going over by 16 when we're going to this point 18. Okay, now we want to go 1/4 that distance, not the full distance. So I'm going to multiply 16 by 1/4, and that gives me 4. Okay. Now, most common mistake is that students stop here. This is a length Okay? This is not your coordinate. You need to take this length and add it to your starting point. So 2 plus 4 gives me 6. That's my x-coordinate. Okay. For the y values, 20 minus 3 gives me 17 times 1/4 gives me about 4.25. Okay? So I need to take that 4.25 and I'm going to add it to where I started, which was 3. So my y-coordinate is 7.25. So I go over 6 and I go up 4.25. That's not exact, but that's the idea of what's happening. Okay, next find the 2/5 point. So this is easier now that we've already gotten our distance. So I'm going to take that original 16 that I had, okay, bring that here, but this time I'm going to multiply it by 2/5. And that gives me 6.4. This is not your answer. This is the length. So you need to add it to your starting point, which was at 2. So 2 plus 6.4 gives us 8.4. And that's my x-coordinate. Okay. All right, for our y, I'm going to take this number, 17, multiply by 2/5. That gives us 6.8. I'm going to add that to my starting point, which was 3. And that gives us 9.8. So that's my coordinate. Okay. 19. What is the range of x values if an acute angle measures 5x minus 50? Okay. Acute angles measure greater than 0 but less than 90. This is what we're going to use to set up two equations where we solve for x. So first, you're going to say 5x minus 50 is equal to 0. Okay. Solving for x, we get 5x equals 50. Divide by 10, x is 10. Or sorry, divide by 5 and we get x is 10. This is your low end. Okay, x needs to be greater than this number. For your high end, you're going to set 5x minus 50 equal to 90. Okay, add 50 to both sides. So we get 5x is equal to 140. Divide by 5. And we get x is equal to 28. Okay? All right, number 20. Ray BD is the bisector, keyword, of ABC. How many degrees is ABD if ABD measures 2x minus 15 and DBC is negative x plus 45? Okay. If this is the bisector, then these are equal. That means you set them equal. So 2x minus 15 equals negative x plus 45. Okay. Add x here and here. 3x minus 15 equals 45. Add 15. 3x is equal to 60. Divide by 3. So x is equal to 20. This is not your answer. It's asking for the measure of ABD. So we got to go plug this back in. 2 times 20 minus 15 gives us 25. That's your final answer. Okay, last problem. E is the midpoint of DF. FE is equal to 7. It wants to know DE and DF. Okay. If E is the midpoint, that means that those two lines are congruent. This is also 7, so DF would be 14. Then it says HG, oh, this is a typo. Sorry, this is my fault. Okay. This should say HG is equal to 7. Sorry. Okay. So this length is 7, HE is 5, then EG would be 3. Make sure to fix that little typo on your own paper as well. Okay. Good luck on your test tomorrow. I wish you the best.